swaps to make the binary string alternating. Okay, this is a beautiful problem because it seems super complicated until you realize what can be the possible outcome. Okay, sometimes when you're doing these problems, the actual result, right, given the constraints of the problem, are so constraining that it can only really be 1, 2, or 3 simple things. And if it can only be one of those 2, 1, 3 simple things, well, then that really frees you up, right, via the constraints, right? When the problem is very constrained, there's only a very few things that it can be, and you can just think about those very few things and solve the problem. Okay, so with that said, let's go ahead and get right into it. So you're given a binary string S. Oh, sounds so scary, right? What does that mean that it's a binary string? That means that it only contains the characters 1 and 0. It doesn't mean it's a binary tree. It doesn't mean it has some sort of magical formulation that determines the reason for existence and what it means to be alive spinning on a floating rock in space, right? It has nothing to do with any of that. It just means it's a string with either 1s or 0s. Simple enough. Return the minimum number of character swaps to make it alternating, or -1 if it's impossible. Okay. The string is called alternating if no 2 adjacent characters are equal. For example, 0, 1, 0, right? So it's 0, then it's 1, then it's 0. Right? It can only be 0, 1. So it's alternating. It goes from 0 to 1 to 0 to 1 to 0 to 1 to 0 to 1. Or it can start at 1, 1, 0, 1, 0, 1, 0. While 0, 1, 0, 0 is not. Why? Because 0, 1 is alternating, 1, 0 is alternating, but 0, 0 is not alternating, right? Your hand's got to do this. You got to go 0, 1, 0, 1, 0, 1, 0. You can't go 0, 0, 0, 0, 1, or 1, 1, 1, 0. It has to go 0, 1, 0, 1, 0, 1, 0, 1, or 1, 0, 1, 0, 1, 0, 1, 0. Da, 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 da. Okay? Any 2 characters may be swapped even if they're not adjacent, okay? So what we need to do is we need to take this string and figure out, okay, can I take this 1 and swap with this 0 over here? Or maybe if this 0 goes over here, if I swap these things around, will it become like that? And how many operations will that take? Okay, so let's look at this example. Always good to look at the examples, all right? So we have S equals 1, 1, 1, 0, 0, 0. And it turns out it's like, okay, 1, 1, 1, 0, 0, 0. But if we take this 1 and move it over here and swap it with this 0 over here, voila, voila. Look at that. It's 1, 0, 1, 0, 1, 0. And how many swaps do we have to do to make that work? Well, we swap these 2 together. So that's 1 swap. And that's why the answer is 1. Would you look at that? All right, our next example, S equals 0, 1, 0. Well, nothing. We don't have to do anything because it's already alternating. So the answer is 0. And then finally, this example, S equals 1, 1, 1, 0. So here you might say, like, okay, well, this one's a problem. So maybe I'll swap it with this 0 over here. But now these 2 ones are a problem. Right, so there's really no way to make this work. Like I can't. Okay, maybe. Okay, well then I'll swap this over here, I guess. Okay, shoot. Well, now that's a problem, right? So no matter how you do this, there's no way to make this work because the 0s and the 1s, like, there's no way to swap this up because if anything, I would need another 0, right? And that's actually a point that you're gonna need to think about in a moment. Right, but this will never work because I don't even have enough 0s to distribute, right? There's always going to have to be a 1 next to another 1 in this configuration. I mean, of this set of 1s and 0s that we have. Right. Look at that. So, this problem's kind of hard because you might think like, oh, maybe it's dynamic programming, right? Like maybe I look at a character and I think about the characters that come before it and I say, okay, if I make this a 1, but I'm not really making something a 1 because I have to swap. And the fact that I can swap anywhere kind of complicates what this is going to look like, right? Because, like here I could say like, oh, I'll start doing swaps, but then you notice like this will never stop, right? Because you swap this over here and you swap it back and then you swap, like you continue swapping forever. So there's not like a simple greedy approach. There's not a simple dynamic programming approach because every time you swap, you have to swap from somewhere else. So how are you going to have like states in that case, because it depends on where you swap from. So that's going to be a mess. So what I was saying in the beginning, right? The beautiful part of this problem is to recognize how constrained it is. And then from that, you can derive a pretty simple solution. And what I mean by that is we're trying to make this thing alternating. Okay? Well, alternating strings can only take two forms. Right? When we look at the first example again, all right? We look at 1, 1, 1, 0, 0, 0. This thing has to be alternating. So what does that mean? It has to go from 0 to 1 and 1 to 0 and 0 to 1 and 1 to 0. So there's only two possible strings that are alternating that are of this length because the problem is so constrained. And what I mean by that is the result is either going to end up being 0, 1, 0, 1, 0, 1. I'm not saying this is a possible string that could result. I'm just saying strings of that length that are alternating, there's only two. It could either be 0, 1, 0, 1, 0, 1 or 1, 0, 1, 0, 1, 0. Right? Those are the only possible alternating strings. There are no other configurations of ones and zeros of this length, of length 6, that are alternating. Right? So I don't need to think about like what swaps with what. I just need to think about, okay, how can I turn this string into one of these two strings? Is that possible? Right? And if it's possible, which one is one of them possible? Is the other one possible? Are they both possible? And which one would result in less swaps? Okay, so if I wanted to turn S into this resulting string, well, I'm going to have to convert this 1 to a 0. I'm going to have to convert this 1 to a 0. I'm going to have to convert this 0 to a 1. And I'm going to have to convert this 0 to a 1. Okay? So I'm going to have to make this 1 a 0, this 1 a 0, this 0, 1, and this 0, 1. And actually, I could do that, right? Because I have zeros that want to become ones. I have two zeros that want to become ones, and I have two ones that want to become zeros. So I could swap this 1 with this 0, and that would make this 1 that it wants to be, and this 0 over here to make this 0 what it wants to be. And I could swap this 1 with this 0, and those two constraints will be met, right? Because I have andale. So I'm thinking about how this would work really quick. I already know how this works. I've thought about it, but I didn't think about how to articulate it. Right? So here, the idea is, well, you know, this guy wants to be a 0. I want to be a 0. I want 0. And this guy says, I want 1. Well, they're a perfect match, right? He's saying, I want to be a 0. He's saying, I want to be a 1. So they can swap. And it doesn't really matter, you know, who swaps with who in terms of like, should this one swap with this 0 or this one swap with this 0? Because both of these guys want to be 1s, right on the right. Right? I want to be a 1 and I want to be 1. Well, I want to be a 0 over here. Well, it doesn't really matter if I swap it with this one or swap it with this one, just as long as I'm swapping it with someone that's going to, you know, fix this constraint. Right? So this 0 can swap with this one or this 0. It doesn't really matter. Right? And this one says, I want to be a 0. So I can say, okay, well, these two could work together, and these two could work together. But again, it doesn't really matter who works with who in terms of, as long as someone that wants to become a 0 works with someone who wants to become a 1. It doesn't matter which, right? I could also do this configuration. Right? I'm just trying to make the point is it doesn't matter. It matters that 0s becomes 1s and 1s become 0s, right? But it doesn't matter who matches with who in terms of this guy can match with him or with him. This guy can match with him or with him, right? But all that really matters here is I have two people that want to become 1s. And I have two people that want to become 0. So I have a match here, right? So I could swap those two. So I could swap these two, then these two, and that would result in two swaps. Okay, that's just one configuration, right? What if I wanted to do the other alternating system here? Be a lot of bogus I'm going to have to delete from this. Good though. So in the other configuration is if I wanted to make it start with a 1, right? Because again, the idea here was there's only two possible alternating strings. So can I convert this thing to one of those two alternating strings? So this is the other one, and where are the issues? Where there's this 1 that wants to become a 0, 1 wants to be a 1, 0 wants to be a 0, 0 wants to become a 1, and 0 becomes 0. So here we kind of have the same idea. This 1 says, I want 0. And this 0 says, I want 1. So I have plus 1 that wants to become a 0. And I have plus 1 that wants to become a 1. So that means I just do one swap. So I get plus 1. So I have two configurations that would work with this system. And I have a +2 here and a +1 here. So the best idea would be to choose this +1, which gives you 1. This 0, 1, 0. Should we go through all 3 examples? I think we should. Really quick here. Because it kind of shows you the different systems of what can happen. So we have 0, 1, 0. So the first string would be 0, 1, 0. Everybody's with everybody. Everybody wants to be what they are, so that's just a +0. But technically, if you wanted to see what the other side looks like, right, you could have 0, 1, 0, where you try the other only possible alternating string, which is 1, 0, 1. And then you would have this case here. You'd say, okay, this 0 wants to be a 1, this 1 wants to be a 0, and this 0 wants to be a 1. This would not work, right? But it doesn't matter because there already is a string alternating that does work, right? Just because one works doesn't mean the other one will, right? Versus the previous example, they both had solutions, right? There were both solutions to make this work. In this case, right, there is a solution that's perfect where it's already an alternating, but if you wanted to make it the opposite alternating starting from 1, well, you're going to have what exactly? You're going to have this 0 wants to be a 1. I want 1. I want 0. And I want 1. So I have 2 that want to become 1s. And I have 1 that wants to become a 0. I can't make this work, right? Because, well, I could match, I could help this guy out and make him a 1 by swapping with this 0, but then I'm going to leave this guy stranded, and he's still going to need to become a 1 to become this alternating string. Or I can match these two together. So the point here is these things, these values need to match, right, in order for this to work, right? They need to have a pair to pair with, right? If I'm a 0 and I want to become a 1, well, then I need to find somebody that's a 1 that wants to become a 0 because they're going to want my 0 and I'm going to want their 1. Right? You got what I'm looking for and I got what you're looking for. So let's make a swap. In this case, there's only one person that wants what both of these other people are looking for. Both of these zeros want to become a 1. So they say, I got a 0. I want to be a 1. Who out there is a 1 that wants to be a 0? I'll take your 1. You'll take my 0. We're perfect. Well, there's 2 people that want to become a 1, and there's only 1 person that wants to become a 0. So there's not an additional 1 person that wants to become a 0 in order for these 2 people to both get a pair match, right? Versus in these examples, that's exactly what happened, right? We had 2 people that want to become a 1. We had 2 people that want to become a 0. We got 1 person that wants to become a 0. We got 1 person that wants to become a 1. So that switch works perfectly, okay? And then we'll look at this last example where it never works in either case, so you can really see this point, drive it home, and then we'll think about what the code looks like. All right, so we have S equals 1111110. All right, in our left example, we'll start with the 0 alternating, right? There's only 2 alternating strings that can exist, and one of them is 0, 1, 0, 1. So when we look at this case, we say, okay, this 1 wants to be a 0, this 1 wants to be a 0, and this 0 wants to be a 1. Right, so we got +2, we got +1 that wants to be a 1, and we got +2 wants to be 0. So it's not going to work, right? Because 2 people want to become a 0. These 2 people want to become a 0, but only 1 person wants to become a 1. So these 2 could work with each other, or these 2 could work with each other, but you can never get both of them to work with each other, which is kind of what we saw in the very beginning, right? We were trying to like figure this out, and we were like, okay, we swap these, but now these person needs to swap. So people keep needing to swap in order to create this alternating string. All right, now what about the other example? So that doesn't work. But who knows? Maybe if we try the other alternating string, like in the previous example, right? The previous example, one alternating string was perfect, 0 difference, versus the other one was impossible to achieve. In this side, the 0 starting alternating string is impossible, but maybe the 1 alternating string is not. Okay, so the opposite alternating string would be 1, 0, 1, 0. All right, in this example, we got... this one's happy. This 1 wants to be a 0. This 1 wants to be a 1. This 0 wants to be a 0. But now we got +0 wants to be 1. +1 wants to be 0. So now there's just one guy straight out here saying, look, I'm a 1. I want to be a 0. Is there any zeros out there that want to be a 1? And this 0 says, nah, I'm good, bro. Everybody's good with where they're at, except for this one guy. So he's alone. So no one's going to want to swap with him. So he has no pair, right? So everybody on the left, everybody that wants to be a 0 needs to have an equal number of people on the right that want to be a 1 so they can swap. Okay, so what's the high idea behind this? Just really quick to kind of summarize. There's only 2 possible alternating strings. So let's try to create those 2 possible alternating strings. It either starts with 0 alternating or 1 alternating. So 0, 1, 0, 1, 0, 1, or 1, 0, 1, 0, 1, 0, 1, or et cetera, et cetera, et cetera. Okay? So then let's look at each string and figure out, okay, if it's going to become this alternating string, what would have to change? Okay, if it's a 1 and it wants to be a 0, all right, or it's a 0 and it wants to become a 1, or it's a 0 and a 0, it's fine, 1, 1, it's fine, right? This 1 stays a 1 is fine, this 0 stays a 0 is fine, but this 1 that wants to become a 0, it's going to need to exchange. This 1 that wants to become a 0 needs to exchange. This 0 wants to become a 1, needs to exchange. 0 becomes a 1, needs to exchange. If there needs to be a change, there needs to be an equal number on the opposite side. For every 0 that wants to become a 1, there's going to have to be a 1 that wants to become a 0. Okay? And whatever that number is, that's the number of swaps you're going to do because that's the number of pairs you can create. So you can either do, in the first example, 2 or 1. 1 is better. In this example, you can do 0 or not possible, because if they're not equal, it's not possible. In this example, it's not possible when you start with 0. It's not possible when you start with 1. This kind of generalizes all possible cases, really, because there's a case where both work, but 1 is better. There's a case where only 1 works, so obviously 1 is better than the one that doesn't work. Or there's cases where neither work. All right. So how are we going to keep track of this? Well, we're going to look at both cases, meaning the case where it's the 0 alternating and the 1 alternating. Okay, so that's what this 0 and 1, Z and big O. All right, and then we'll keep track of, this will be the number of 0s that want to become 1s, and this will be the number of 1s that want to become 0. So these should be equal at the end. And this is the same thing, but for the other case. Okay, then we're going to look at each character in enumerate S. Right now, we have an alternating string here, right? So either starts at 0, it's either 0, it starts at 0, it starts at 1, and then it goes like that onwards, right? So a way you can capture that is to look at this. If I do I mod 2 and I mod 2, I plus 1 mod 2, you're going to see an alternating string. Right, you're going to see the alternating 0, 1s because we want to create that 0, 1, 0, 0, 1 pattern that we can compare to, right? Because what we basically did in this problem, right, is every time we saw a string, we created this alternating string so that we could make the comparison. So we need to create this alternating string to make that comparison. So you see how this is 0, 1, 1, 0, 0, 1, 1, 0. So let's do end line. I forgot how to do this in Python. How do you do end line? End, maybe? Because in Python, there's no print line function. All right, here. Okay, so 0, 1, 0, 1, 0, 1. Right, so that's how you can get the alternating string. That's the point I'm trying to make here, because we're trying to create this alternating string that we can reference. And you can also do another alternating string if you just do I plus 1. So this is modular arithmetic, right? Which is, so 0 plus 1 mod 2, it'll always stay in the space 0 to 1. If you don't understand modular arithmetic, you should probably study that before you even attempt any medium, right? There's a lot of fundamental topics that you need to understand, and modular arithmetic is definitely one of them because it's a good trick to do there's a whole set of problems that just utilize modular arithmetic. So understand that. And this is kind of just a little trick to handle that, right? So I can create both alternating strings by doing I plus 1 mod 2, right? Because I goes through the whole array, or I mod 2. Okay? So we'll look at both strings and we'll use this I plus 1 idea. All right? So if C doesn't equal I plus 1, C is going to be a string, so we should convert that to a string. I plus 1 mod 2. So I plus 1, I is initially 0, so this would be 0 plus 1 is 1, mod 2 is 1. The string of that is the character 1. Then this would be the starting at 1 index, and we'd say 1 at I plus 1 mod 2 plus equal 1. Which basically means that, okay, one of them is going to need to change places, right? If it's a 0 and it's supposed to be a 1, then the 0 or it doesn't really matter because you could do this so many different ways, but I'm just going to do it like that. All right. And then we do the same thing for the other thing, right? So this would be the string starting at, sorry guys, it's so hard to, I don't want to explain. It's so hard because sometimes you don't know exactly how much you're supposed to explain. If you're over explaining, you know, the code, a lot of this you should know how to do already. And there's also some implications about, it doesn't really matter, like if you populate this one when you're supposed to populate this one, because it's just the difference, right? If you count, all that matters is that the zeros that want to become 1 are equal to the ones that want to become a 0. So if I accidentally count the ones that want to become a 0 as the zeros that want to become 1s and the ones want to become 0, like if I reverse them, it doesn't matter because all that matters is that these two things are equal. Hopefully that makes sense. Right? But this is basically one of the strings and this is the other one. But if this is the one that starts at 1 and I reference it in 0, like, so there's a lot of freedom here in terms of actually how you're accounting. Right, because it's possible that it doesn't really matter as long as you capture both cases. Hopefully that makes a little bit of sense. All right, we'll put this on one line. And then just for the posterity, we will print Z at the end, and we'll print O at the end. And you might see that Z, I said Z was representing the one that started Z, but maybe it's the one that starts at 1, and it doesn't really matter. Okay, so for this first example, well, this is kind of exactly what we saw, right? So we have 2, 2, and 1, 1. Does that look familiar? Well, that's this 2, 2, and 1, 1, right? So that's what this represents here, right? Because every time they're not equal, I add 1 to the ledger for that character, and vice versa, and et cetera. So, right, every time they're not equal, I add that. So then how would I figure out the solution here? Well, I'd say, okay, let's say res is float infinity to start. So res will be my solution. And I'll return res at the end. Or we'll say, okay, if z0 equals z1, so what that basically means is if there's the same number of things that want to become a 1 as things that want to become a 0, well, since I haven't populated res yet, I'd say res equals z0, because that's the number of swaps I'm going to make, right? Here I make 2 swaps. Here I make 1 swap. I say if 1, 0 equals 1, 1, res equals the min. Now I have 2 things I can track, right? It's either what I think the min is, whatever, if it's the best of this solution and this solution. So I'd say 1, 0. Maybe someone can tell me a better way of, so it's either using 1s or whatever I think 0, 0 is. And I'd say, okay, at this point, if res is still negative 1, because if it was negative 1 here, no. So if res equals float infinity, meaning that neither of these things were true, we return negative 1. Otherwise, we return res. Does anyone know in the comments, please, if you're still watching this, tell me a better way of doing this, because this is so messy. But it's kind of hard because you have to capture both cases, but you have to also ensure that both cases work, and you have to capture the fact if neither of them work, you have to return negative 1. All right. So what is the run and space-time complexity of this? All right. So let's say that n is the length of S. For time, well, we create this constant time. We look at all n characters. We do a constant comparison, a constant add, constant comparison, constant add. So for all n things, we do constant things. So we do n constant things. So this is big O of n. It's a constant operation, constant operation, constant operation, constant operation, constant operation. So constants, n constants, that's big O of n. For space, we create this thing of size 2. We create this thing of size 2. We populate it with the variables as we continue. We do a bunch of constant operations, and we return a constant thing. So that's big O of 1, right? No matter how long the string is, we only create these two, this array, four array slots, I guess, and it never gets bigger than size 4, so it's constant, all right? All right, guys, hope you guys have a beautiful rest of your day. Somebody, please, in the comments, tell me how to write this better. Later.